Good morning, student. Now, welcome to today's class. In today's class, we are going to discuss about transistor biasing. Okay, this transistor biasing. Okay, in previous classes we have studied about the connection of transistor. Okay, the characteristic of input characteristic and output characteristic of each connection. Okay, so now let us see the transistor biasing. Okay, the transistor the transistor, how can we bias? Okay, now before before we can study about the transistor biasing, we should know about the faithful amplification. Okay, what is faithful amplification? The process of raising the strength of a weak signal without any change in its general shape is known as faithful amplification. That means this is called, that means for raising the strength of the signal. Okay, raising the strength of the signal of um, strength of the signal of or the strength of the given signal or weak signal which is given to the input of the transistor. Okay, by not changing any shape of the signal, it's called faithful amplification. Okay, then then the theory of transistor reverse reveals that it is it will function properly if it, it is input circuit, if its input circuit, that is base emitter junction, okay, remain forward bias, and the output circuit, that is collector base junction, remain reverse bias. Okay, always remember the the transistor circuit, always the transistor circuit should be, or the input of that transistor circuit should forward biased, and the output circuit of the transistor circuit should do reverse bias. Okay, should be reverse bias. Okay, that is the main rule of a transistor uh, working. Okay, or transistor circuit. Okay, then then this is the key factor of achieving faithful amplification, and this is also the key factor of achieving faithful amplification. To ensure this, the following basic condition must be satisfied. Okay, one is proper zero signal condition collector current. Okay, then the second one is minimum power base emitter voltage, minimum proper base emitter voltage to any instant, then minimum proper collector emitter voltage to any instant. These three conditions should be satisfied for the for ensuring that this upper condition, which is the input circuit is forward bias and the output circuit is reverse bias, that condition should be satisfied. Okay, so now let us see the three conditions. Okay, proper zero signal collector current. you know you know IC. Okay, this IC, let's say if you give this signal to the input circuit. Okay, this is input circuit, and in the in the positive in the positive cycle. Okay, in the positive cycle, this is positive and this is negative. Okay, so this one is forward bias. Okay, because this is NPN transistor. Okay, you see this is NPN transistor. Okay, so this N is negative bias and this P is positive. So this is forward bias. Okay, so the input is forward bias, so the current is flow in the uh, so current is flow through the, due to this forward bias, the current is flow in the IC and in the IB. Okay, this is leakage current, base current or leakage current, small amount of current is flow. So here IC, IC, IC equal to IB plus I, sorry, huh, sorry, 1 minute. Here output, okay, this output current, okay, this output current is, or uh, the uh, the output current here, the forward, the input is forward biased, okay. This will be uh, caused a base current, okay, and much larger collector current flow in the circuit, okay. This is due to this forward bias, this base current is flowing, okay, and this, due to this base current, the collector current is greater, okay, or higher, okay. So we get our output amplified output, okay, for this positive cycle, okay. But in the negative cycle, this is reverse bias. Input of the transistor circuit is reverse bias, and for this reverse bias there is no current flow in the IC, okay, because the transistor is in off state, okay. So there is no current. So here, for negative cycle of the signal, there is no amplification, that is means there is no output signal. So this is called on-path application. On-path application means only one part of the signal is amplified, another part is not amplified or uh, suppressed, okay. So this is on-path signal, okay. Now for overcoming this problem, okay, we use one voltage, okay, one voltage source VBB in the input circuit, okay. So here you see, when positive cycle, in positive cycle, the IB is this is forward bias, and due to this extra VB, this is also highly forward bias, okay. Then this IB is more, okay, and this IC is little bit more, okay. So we get our amplification for positive cycle, and in the negative cycle, this is for the negative cycle only, this is for reverse bias, but due to the presence of this voltage source, this is forward bias, okay. This input circuit is also forward bias in the negative cycle of the information or message, okay. So due to this, due to it is forward bias, the IC is produced, okay. Then we get a amplified signal output for the negative signal of negative cycle of the signal also, okay. So this is called faithful amplification. That means we get total amplification for positive cycle and negative cycle of that uh, message signal, okay. This is called faithful signal, okay. So for faithful signal, the proper zero signal collector current is needed, okay. Here you see, proper zero collector current means there is the you see you see the magnitude of this voltage should be such that it now introduce a battery, okay. VBE is the base circuit as shown in figure. The magnitude of this voltage should be such that it keep the input circuit forward bias even during the peak of the negative voltage, when no signal is applied, a DC current, okay, IC will be flow the collector circuit due to the VBE. That means when there is no signal here, there is no signal given. So due to this VBB, the in the circuit, this input circuit is forward bias, so there is so small current flowing in the IC, okay. That is the forward bias, even the IC of half cycle, when there is no signal applied, a DC current IC is flowing in the collector circuit due to the VBE as shown in S1. This is known as zero signal collector current. Okay, this small IC, is called DC IC. Okay, and in the total IC is the IC current. Okay, and the small IC. Okay, and zero, that is called zero signal collector current. Okay, when there is no signal, the small called DC collector current is there. Okay, then zero signal collector current should greater than equal to max collector current due to the signal alone. Okay, now the next property is proper minimum base emitter voltage. Okay, in order to achieve faithful amplification, the base emitter voltage VBE, okay, should not fall below 0.5 volt for germanium and transistor, and 0.7 volt for silicon transistor at any instant. Okay, that means it said that in the transistor, okay, in the transistor, this is B, this is emitter. Okay, so V B E, this voltage should not less than 0.5 volt in germanium transistor case, and 0.7 for silicon transistor case. Okay, because when there is because when or below that voltage, okay, this is the barrier. Okay, for germanium transistor, okay, the barrier, okay, the potential barrier is 0.5 volt. Okay, in the silicon transistor, the potential barrier is 0.7 volt, and whenever you applied less than this voltage, then the current would not flow, or the charge cannot cross the barrier. Okay, so there is no current flow. Okay, so for proper functioning or current flow, the VB is always 0.5 volt, greater than 0.5 volt or 0.7 volt. Okay, then proper minimum VCE at any instant. Okay, the VCE means VCE for faithful amplification, the collector emitter voltage, okay, should not fall below 0.5 volt for germanium transistor, and 1 volt for silicon transistor. Remember this. Okay, this is known this this is known called knee voltage. Okay, previously we have studied about the knee voltage. Okay, then when VC is too low, or 0.5 or 1 for silicon, the collector base junction is not properly reverse biased. Okay, and therefore the collector cannot attract the charge carriers emitted by the emitter. Hence a greater option is of them goes to the base. Okay, this decreases the collector current while base current increases. Okay, hence the value of beta is fall, because the beta is, you know, the beta is IC by IB. Okay, whenever this IB is increased and IC is decreased, okay, so the value of beta also decrease. Okay, this is called current amplification in the common emitter case. Okay, beta is current application factor in the common emitter case. Okay, so you should always the VCE should always 0.5 volt to greater than 0.5 volt or 1 volt. Okay, now let us see the transistor biasing. Okay, we know about the faithful amplification. It is already have discussed that for a faithful amplification, a transistor amplifier must satisfy three basic conditions, namely proper zero signal collector current, proper base emitter voltage at any instant, and a proper collector emitter voltage at any instant. Okay, it is fulfill the base fulfillment of this condition which is known as transmitter biasing. Okay, in transmitter biasing always or transmitter biasing is for the fulfillment of these three conditions. Okay, the proper flow of zero signal collector current and the maintenance of proper collector emitter voltage during the passage of signal is known as transistor biasing. Okay, then the basic purpose of transistor biasing is to keep the base emitter junction properly forward bias and collector base junction. This base emitter junction is input circuit always forward bias, and the collector base, which is output circuit, is properly reverse bias the application applied signal. Okay, for this we use transistor biasing. Okay, this can be achieved with a bias voltage or bias battery or associating a circuit with a transistor. The latter most method is more efficient and frequency employed. Okay, the circuit which provide transistor bias is known as biasing circuit. It may be noted that the transistor biasing is very essential for proper operation and transistor in any circuit. Okay, so transistor, why we need transistor biasing? We need transistor biasing for satisfying our condition. Okay, for which that condition needed for proper working of transistor. That condition is the input circuit of that transistor should be forward bias and the output circuit should be reverse bias. Okay, and this biasing is done by any achieved by biasing battery or associated with a circuit which with a transistor. Uh, this biasing is achieved by connecting a biasing volt battery or a circuit biasing circuit with the transistor. Okay, now in the coming classes we have seen uh, mm, we will see that the type of biasing of transistor biasing. Okay, different type are there. Okay, the biasing circuit, different biasing circuits are there. These are these were shown or we'll see this different type of biasing circuit in coming classes. Okay, for these classes that was that's all. Thank you.